Memory profiling in Unity. Why your game crashes when players save. Hello and welcome to episode number 7 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever shipped a game that ran beautifully for 20 minutes, then suddenly crashed when players try to save their progress? Or maybe your loading screens take forever and you have no idea why. Sounds familiar? If so, this episode is for you. Today we're talking about memory profiling in Unity. And I promise you, by the end of this episode, you'll know exactly how to track down memory hogs, avoid those mysterious crashes, and maybe even cut your loading times in half. Let's start with the why. Why do you even need to profile memory? Simple answer, you need to keep your memory at bay. That means staying within your memory budget. And yes, you should have a budget. If you followed my P3 optimization framework, step 1 is defining performance goals. One of those goals, your memory budget. Here's where it gets interesting. Let's say you're developing for Quest 1. You might think, hey, Quest 1 has 4 GB of RAM. I'm golden. Wrong. Dead wrong. You only get about 2 GB. The operating system and the greedy Oculus software eat almost half of that capacity. So first, define your budget. Second, track it religiously, because if you don't measure it, you don't know it. And if you don't know it, you're gambling. Picture this scenario. You're building a shooter. Players grind for hours, they hit save, suddenly you're serializing a ton of structures. Memory spikes, the OS decides it's had enough and kills your app. No warning, next time the player opens your game, corrupted save file, 1-star review, angry Reddit post warning others to stay away. Not a good day. Oh, and here's a bonus. Loading times are directly related to memory usage. The less memory you load, the faster your load times. General rule of thumb. So if you want to hit that magical 3-second loading mark, memory profiling is a great place to start. Alright, so what is memory profiling? It's all about gathering numbers related to memory, specifically memory usage, not bandwidth. You're finding out how much memory you're using, how much headroom you have before you hit your budget, and most importantly, who's stealing that memory and getting away with it. Maybe you've got a high poly car model eating 100 megabytes. You need to know that, because that might be the first thing you optimize. Now, how do you actually do memory profiling? Your entry tool is the Unity Profiler. Press Ctrl 7 or Command 7 on Mac. Done. Yes, there are other tools. If you're on Android, you've got ADB shell dump mem info and a bunch of lower level options. But here's the thing. Those tools show you raw bytes. Unity knows what Unity is doing with memory. Unity tools speak Unity's language. Start there. The Unity Profiler has 2 modes, simple and detailed. Simple mode gives you the big picture. Total memory usage. Memory split by category, textures, meshes, audio, animation clips, and so on. Detailed mode answers the second question. Who is using this memory? It breaks it down per asset. It even tells you who's referencing that asset, so you can track down every GameDev spotter or material that's holding onto that 10 megabyte texture. Let me walk you through a real example. Open the Unity Profiler. You see a timeline, just like the CPU usage view. On the right, the current frame. On the left, about 300 frames back, depending on your settings. You can toggle filters on or off to see trends over time, useful if you're loading levels or doing long operations. Focus on one frame. You'll see total used memory and total reserved memory. Reserved is usually bigger than used. Why? Because when you spawn a process, memory tends to grow but rarely shrinks. If you reserve 2 gigs at some point, that's what you'll have until the user closes your app. The OS cares more about total used memory, so that's your critical number. Now look at the categories: textures, meshes, audio, animation clips, and so on. There's no perfect ratio. It depends on your game. If your game is texture heavy, textures will dominate. If it's animation heavy, animation clips will be bigger. The key is always stay below your budget. Let's say you see 200 megabytes in meshes, 33.9 megabytes in textures, 2.6 megabytes in animation clips. Where do you start optimizing? Not animation clips. 2.6 megs? Who cares? Maybe 30 years ago, but not today. Start with textures. That's where you'll get the biggest gains. Now let's go deeper. Switch to detailed mode. Make sure Gather Object References is disabled for now, otherwise it takes forever. Then take a sample in play mode. You'll see three main categories: assets, others, and scene memory. Assets are everything you imported: characters, textures from Photoshop, models from Maya. These are the names you'll recognize most. Open the textures category. The list is sorted by size. Boom! There's a building normal map taking 10 megabytes. Click it. Unity highlights it in the project view. Check the inspector. Now you see the texture import settings: read-write enabled, streaming bitmaps, max size, compression format. We'll dive deep into those settings in future episodes, but today you just need to know this is where you go to optimize. Maybe you reduce the resolution. Maybe you change the format. Maybe you tweak MIP streaming. The point is, you found the culprit. Now let's talk about the others category. This is mostly overhead. Things like burst compiler service, frame debugger, profiler memory itself. You might think you have no control here, but often you do. We'll cover that later. Finally, scene memory. This is stuff created at runtime. Render textures, combined meshes from static batching, procedural geometry. If you open the mesh category, you'll see static batching data, because static batching happens at the scene level. It merges meshes together so you can draw them in one go. If you click an item here, Unity takes you to the hierarchy, not the project view, because these assets live in the scene. Alright, here's the critical part. You'll see this message at the top of the profiler. Memory usage in the editor is not the same as it would be in a player. Do not ignore this. This is not a casual warning. This is critical. Let me show you why. I create a new empty scene. Skybox, nothing else. I open the profiler, record a few frames, take a sample. Look at the memory. Way less than before? Great. But wait, profiler is taking 500 megabytes. Burst compiler service is eating memory. Frame debugger is using memory. Does the player care about any of this? Nope. This only happens in the editor. Here's the kicker. I close Unity, reopen it, play the scene, take a snapshot. Stop. Now I click on a random texture in the project view. A cactus normal map, 5 megabytes. I don't have it in my scene, I just clicked it. I play again. Take another snapshot. Now look at assets. Suddenly 30 megabytes of textures are loaded. The cactus, buildings, dropship, they're in memory, but they're not in my scene. Why? Because the Unity editor is hyper-optimized for fast iteration. When you click an asset, Unity loads it into memory so you can preview it, assign it, whatever. Once it's loaded, why would Unity unload it? Next time you need it, boom, it's already there, super fast. As a developer, you're thankful for this. If Unity had to reload every asset every time you clicked it, you'd be furious. But this means the editor eagerly loads everything it can, even if you don't need it. That's the opposite of a player build. Let me prove it. I build the empty scene for Quest. I attach the profiler to the build. I check memory. 14 megabytes of textures. I take a detailed sample. I check assets. Almost empty. In the editor, over a gigabyte. In the build, 14 megs. That's the difference. So here's the rule. If you need accurate memory numbers, profile on your target device. No way around it. However, if you just need rough numbers, or you're tracking references, or you're doing early stage work, profiling in the editor is fine. Just know the limitations. Now let's talk about the Gather Object References option. Enable it, take a sample, and Unity tells you who's referencing each asset. Super useful if you need to understand why something is loaded or if you're trying to get rid of an asset. But again, in the editor, this list is full of noise. Sometimes the only reason an asset appears is because you selected it in the project view. The editor itself shows up as a reference. That's not helpful. On the target device, what you see is what you get. In the editor, what you see is not what you get. If you're cool with that, I'm cool with that. So when should you use the Unity Profiler for memory? Every now and then, just to track how your project is doing. Projects get more complex over time. Make sure you're not creeping toward that memory ceiling. Profile before every major release, or any release honestly, just to make sure you're good. If you're seeing random crashes, especially during scene transitions, that's a red flag. Time to profile. And here's the secret. The Memory Profiler is a fantastic way to find assets you're loading that you shouldn't be. This helps you reduce loading times. Fewer bytes loaded equals shorter load times. That's a rule that works pretty damn well. When should you not use the Unity Profiler? Avoid profiling the editor in play mode unless you know what you're doing. If you don't know what you're doing, you'll get misleading numbers. Don't profile during prototyping? Who cares? Prototyping is about getting testable results fast. Optimization comes later. And here's something most people don't know. If memory is allocated outside Unity's control, Unity won't know about it. Example: Wise, the audio plugin. It has its own memory profiler. Why? Because it does its own memory management. I once had a project where Wise was eating 500 megs out of my 2 gig budget. Unity said everything was fine. I checked the command line, Unity was lying. Not everything you see in the profiler is 100% accurate. Be careful. Alright, let's recap. Memory profiling is essential. It prevents crashes and reduces loading times. Start with the Unity Profiler. It has two modes. Simple gives you the numbers aggregated by category. Detailed gives you per asset breakdowns and reference tracking. If you profile in the editor, know the limitations. What you see is not what you get. For accurate numbers, profile on the target device. And remember, the Unity Profiler can still lie, especially with third-party plugins that manage their own memory. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time!